One tool. That is the entire allowed list. I handed this AI agent Grep and nothing else. No file reader, no shell, no way to list a directory. Then I asked it to trace an HTTP request through a framework it had never seen. It used 4 tools, the one I granted and 3 I did not. No tool was blocked. Nothing warned me about the tools. In my last video, I gave a piece of advice. If your agent only needs to read code, do not give it a shell. Give it read and search instead. This video is that advice, tested at its harshest search, without even a reader. Same question, same codebase, 2 runs. One with the allowed list I thought was a constraint, and one where the constraint was real. Here is the whole setup. Allowed tools. Grep. The target is Flask, pinned at version 3.1.3, 83 Python files, read-only, and 1 question. Trace what happens to a single HTTP request, from the WSGI entry point to the moment a view function runs, and its return value becomes a response. And say so if you are guessing. Now watch the first thing it does. Not a search. A shell command, walking the entire file system looking for Git directories. It does get refused, but look closely at why. The refusal is not about the bash tool at all. It names one fragment of that command, the part that needs approval. The next command, plain and simple, runs with no prompt whatsoever. So the allowed list is working. On commands. Just not on tools. Last time I showed you that an allowed list pre-approves rather than denies. Write was offered, refused, and the agent routed around it. Here there was nothing to route around. Grep, Glob, and Read are documented as requiring no permission inside the working directory. For those tools, inside that directory, there is no boundary. One line changes that. Not a longer allowed list, a deny list. A bare entry in disallowed tools removes the tool definition from the request entirely, so the model never sees that the tool exists. That is documented behavior, and it is the only difference between the 2 runs you are about to compare. Same script, same prompt, same target. 1 extra line. Now search really is all it has, and the first thing you notice is one tool doing 2 completely different jobs. The opening queries ask where something is. Output mode set to files with matches, paths only, no contents. 44 files come back for the first one. That is not reading. That is building a map of where to look next. Then the mode flips. Content with line numbers and 30 lines of trailing context. That is a search tool being made to behave like a file reader, a pattern broad enough to pull the top of a method out of the file behind it. It half works, and the half that does not is the next thing you will see. It is also the moment you realize how much of reading code is really just aiming. And then the best moment in the run. It wants to see a specific span of the file, lines 1506 through 1529, so it searches for the line range. It hands a pair of numbers to a tool that matches text, not positions. No matches found. 1 query later it recovers, and the recovery is the whole technique. Stop asking for a position. Ask for content. It anchors on a string it already knows is in there, the line that builds the request context, and asks for 22 lines after it. And there is the method body, read by search. That is what living without a file reader actually looks like. It could not ask for lines 1500 to 1530. It could only ask, find me this text and show me what follows it. The agent worked that out by failing once, which is honestly how the rest of us learned it too. Then it does something I did not expect. It works out that the URL matching code is not in this repository at all. It lives in a separate package, and it goes after it anyway, searching from the root of the file system. And it runs straight into a limit, live on camera. Rip Grep search timed out after 20 seconds. So here is what the constraint cost. The run, with 4 tools, answered in 5 Grep queries. The search-only run took 10. Twice the Grep queries, for exactly the same question, though fewer tool calls in total, 16 against 10, because the unconstrained run spent most of its calls reading and listing instead. It also took longer on the clock, 81 seconds against 58, although it needed fewer turns to get there. That is the price. Now the part that actually matters. What did it buy? I wrote out the true call chain by reading the source directly, full file access, which the enforced run never had. Then I listed 11 specific places where finding the right string leads you to the wrong conclusion. Traps. That is the grading sheet. Both runs cleared the same 6 traps. Both walked into the same 4. Not a similar score, the same profile. Both saw that routing happens quietly inside the context push, before dispatch ever runs. Both missed that part of the error handling lives in a second file, which a search scope to the main file can never reach. 3 differences, and they do not all point the same way. The for-tool run was sharper on the error path. It named the second route to a response, the one that skips the normal pipeline. The search-only run was sharper on the wrapper that sits before your view, and it carries one error the other avoids, a signal in the wrong method. So, twice the queries, for an answer that is comparable and very slightly shallower. Not better, not much worse. My last video said give it read and search instead. This is the bill for that advice at its harshest. Search alone, without even a reader, and I think it is a fair bill, but it is a bill. Now here's the part one got wrong. While I was writing this video, I thought I had caught the agent making up a citation. Here is query 9. It searches for the definition of the error handler lookup, scoped to the main file. Only one of the 3 names comes back. The definition it wanted lives somewhere else entirely, and yet the final answer states that call with its exact argument list. Which looks like a claim made out of thin air. It is not. 5 queries earlier, it had matched the containing method at line 779 and asked for 25 lines after it. 779 plus 25 is 804, and line 804 is that exact call, so why could I not see it? That is my own capture script. 20 lines printed in my capture, trimmed further here for the screen, then a count of what it dropped. 157 more. 20 plus 157 is 177. The size of the result the model actually received. The cap is on my display. The agent saw line 804. I did not. And you should not take my word for that, so this next block is not from the capture at all. It is the same query, run again today against the same pinned commit. 177 lines, exactly as the arithmetic said. And 6 rows past the point where my transcript stopped printing, there it is. So here is the rule I actually took away, and it is bigger than this video. From a truncated capture transcript, you cannot support any claim of the form. The agent asserted this without having seen it. A display cap puts that permanently out of reach. If you want to make it, you need the full tool results. And look at the shape of what happened. A search cannot tell you the difference between this is not here and this is not anywhere, the whole difficulty of the search-only run. Then I read its transcript and could not tell the difference between it never saw that line and it was not printed. The same mistake, twice. 3 things to take away. First, search only is a real constraint with a real price, about double the queries here, for an answer of roughly the same quality. Second, a search cannot tell you the difference between not here and not anywhere. Finding nothing is never evidence of nothing. Third, your capture transcript is a trimmed view of what your agent saw. Do not audit it as though it were the whole thing. If that was useful, subscribe.